Hello? Is anyone there? Just me talking to myself? Moose, hello. Hello. Connor, hello. Quecko, Harmony, hello, hello. Almost no off the stream work today. One tiny little fix that I wanted to do before while I was fresh in my mind. But other than that, it's the same shit that we had from Sunday. White shirt tonight, correct. Arla, hello. Media, hello. Sar, hello. Lot to do today. A lot to do every day. But a lot to do today. Well, over in the UK, that would be a dinner jacket, not a tuxedo, but also correct, no dinner jacket. Mercer, hello. Prism, hello. Harand, hello. Hello. No Discord notification because I forgot to do it. Give me 1 second. How do I do this? How do I alert management? Alert. Done. Thank you. I know, right? Expecting another early stream raid. We should always be not expecting, prepared for. I never expect a raid. It was just a nice thing when it does happen. I'm using trunk GCC, so it's as much 26 as anyone has supported anywhere. So it's got reflection, it's got contracts, it's got a lot more of the context for stuff. Yeah, it's got some good stuff in there. AC, hello. Julian, hello. Right, let's have a quick look at where we at. So the last thing. So I extended the level bit off stream just because I've actually been having a little bit of fun playing around with the level editor. Like it needs a lot of work. It's quite clunky to use, but now when we walk down from the starting, we have a nice little corridor. Yeah, key cat pick. Let's go. And then you get a nice dead end here. So that's something to look forward to. I need to seal off all these doors because they just go to the void. I put a little widget on the wall. Don't know what it does, but it was a little widget I could put on there, which is cool. And then I extended the big room. So in here we now have a generator of sorts. Don't know what's generating, but it's certainly more interesting. Still a bit of a roofing issue here. It looks like a UK primary school at the moment. And then in the other room, I just put a big fan on the ceiling because I could. So that's where we're at. And then here's still in the void. So that's where we're at. So it's a little bit more interesting. And obviously, you kind of still got all the old gubbins that go along with it. I put some lights in these rooms, so still a light up here. I just meant like the roofs collapsed because the UK government cannot build schools out of bricks that aren't made out of paper. Yeah, so we got all that, which is cool. All this is all pretty tickety boo. Okay, right. So the only thing I think I did was there was some. I got myself in a little bit of a state trying to work on the drain for the thread pool. Because I was like, oh, there's definitely a race condition here. So I simplified it also. There's no longer like 2 atomic booleans. Well, there's no longer 2 atomics. There's just 1 atomic, which is the count. So this will wait until the count is 0, and then the count is atomically incremented when it pushes a job in, and then when it takes one out. And then I was like, well, hang on, what happens if like I remember like right at the end of the stream, I was going through it step by step, and I was like, well, if it gets here, then that's fine. Then once we get out the loop, then another thread comes in, and I was like, I'm being stupid because the contract, the expected usage for thread pool is that this is called from main to wait for all the child jobs to end, right? So once child jobs is 0, no one can put any more jobs in until after drain has finished returning, right? Like, right? Because the whole point is this is a synchronization point for main. So I think it's fine. So there's going to be other race conditions in here because I wrote it and threading is hard. But I think other things that we need to do, I'm not going to do today, but I realized that in our basic thread primitive, this is fine, but so it captures the exception, but like thread pool just like does absolutely nothing with it. So the idea is that this drain should check for any thread objects that had thrown an exception and then rethrow them from drain. So it percolates up to main, so main can then grab it and then print a stack trace. So I think that's fine. I think we just need to wire that in later. That's easy. I think that's just mechanics. So I may end up doing that off stream and then write some tests for it. I don't know. What I want to do today is coroutines, right? I want to write some coroutines because coroutines are fun, and the coroutines is the interface, the bridge, whatever, is how we get to threads. In normal engine code, not careful that word there. In normal game internals code, not many things should be using the thread pool directly. I suspect Jolt will have to, but by and large, things should be creating tasks, and tasks in the background get farmed out to threads. So as we as a user, right, of the game internals, not an engine, we as a user of the internals, right, those of us writing main, shouldn't really have to think too much about threads. We should think about jobs. And jobs are going to be tasks. I don't know, right? Jolt was multi-threaded, right? From my reading of it, Jolt has a way of hooking is a customization point, right? So you can basically tell it how to farm stuff out to jobs, farm stuff out to threads. Now, Chrism, isn't that a great question? And here, I'm not saying it keeps me up at night, but it's definitely one that I lose a lot of thought over, is do we rethrow all thread exceptions or just the first one? It might not even be the first one. It might be the first one we find in a loop, so whichever one is first in the underlying vector that threw. I think about this quite a lot because is there a chance that the first exception could then cause other exceptions in other threads? So is it important that we capture the first exception, or is it just enough to know that an exception was thrown and something bad happened? Jolt should still go through tasks, so when you see how we do coroutines, it might not make sense. Maybe, I don't know. Like let's start writing some code and we'll get to it. I suspect I'm prepared for Jolt to be slightly special cased, but still use the thread pool. So we'll see. But I definitely want Jolt to be multi-threaded, right? There's no reason why it shouldn't be. And as we've gone to the effort of writing a thread pool, there's no reason why it shouldn't use that. But we'll see. Right, so let's do source concurrency task.h. Right, I'm going to write myself a nice little task. Is the font size all right? I feel like the font size is smaller today, but I can't really tell if that's right or not. So task is just the name we're going to give to our coroutine object, the thing that asynchronous functions will return, which captures the coroutine handle. So I've been thinking about this as well. I think I want this to be. I think I want both lazy and eager coroutines, i.e. ones that immediately start and ones that just wait to be scheduled. Yeah, I'm still trying to work out how the best way to overlap is, because someone said, like, so I originally had this and they're like, the green is distracting, so I put it down here. I think I might just need to make that transparent background not transparent, but I'll have a look at that now. I don't think I can change that live, or if I do, I don't know how, so maybe I'll just make that fully transparent. Okay, so let's do eager, all right. So the way coroutines are a little bit strange in C++ because I'm gonna probably not. I can't remember. Let me start again. Nope, I'm stuck. We did coroutines in the last project. I can't remember exactly the sort of interface that we came up with. I think it was all right, but I definitely don't want that again. I can't remember how much detail went into explaining how coroutines work. So I'm probably just going to be writing these and just talking about it as I go along. So there might be more like intro information in the previous streams, but do stop and ask questions. So you have to have a promise type, right? Because there ain't no coroutine unless there's an internal promise type. Okay, so you can call your you can call your task whatever you want. This name is irrelevant. It can be a template. It is irrelevant. It has to have access to a promise type, either an internal struct or a member type or something like that. But you have to have it typed and cased exactly like this. And then we basically have like auto so return. We have to have a bunch of special functions in here. So I'm gonna have like return void because I don't want my coroutine to return anything. So you will not be able to co-return or co-yield anything, but that's fine because calculating values and passing them out is not really how I envision the this is purely an interface into getting threads to execute your code. So a coroutine is just a function that you can suspend, right? So if you think of a regular function or subroutine, for want of a better word, it runs at the top and it keeps going until it hits return. Coroutine does the same, but it is the option of pausing at any point, return to the sender, and then you can resume that at any point you want, right? And the thing that the function a coroutine returns is this object, which you'll see will allow us to resume it. Quite a lot of words there. Also, what's the other ones? There's a couple of them. I always forget them. Unhandled exception. So this we'll need to implement later because we're going to want full exception support in this. But for now, I think we're just going to go unhandled exception, and then we go auto initial suspend. Right. I'll do the implementation of that in a second because that's the interesting one. Auto final suspend no except. Sorry, that's going to return a stud. Suspend never. Suspend never. Got it. No except return. Right. So these are basically customization points, right? So coroutines under the hood just work as a state machine, right? That's all they are. They're a state machine where the compiler generates for you, and one of the main parts of the state machine is it automatically dynamically allocates your stack variables and persists them on the heap for you, so that when you resume, you can reconstruct your stack. Async is just like another language's keyword for doing coroutines, right? Coroutines is you could think of as like the mechanism under the hood. So async is a great example, right? Because in Python and C#, right, and probably other languages, async just works. Like C#, you still have a task templated on the thing you want to return, right, or genericized. But it just works on the hood. C++ is like, don't we make any assumptions for you? So how about you define how everything works? And as you'll see here, these are all customization points. So when the coroutine is initially called, like this function, the return value from this function will define whether the coroutine starts in a suspended or non-suspended state, right? And then when it's finished, so when you hit co-return or fall off the end, which is an implicit co-return, this function will be called for you by the state machine, and this you'll be using to say, do I want to leave the coroutine in a suspended state when it's returned? And I'm going to be like, no. The only reason you would want to leave it in a suspended state is if you're returning something out of that coroutine, in which case you don't want that to be destroyed until you've had a chance to use it. So you'll then need to get a promise type and blah, 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 which means you then have to do additional cleanup. So this will make things auto clean up for themselves afterwards, and it makes our lives slightly simpler, right? If you want to store something, you would instead create a return value function, so return void. Return value doesn't return anything, obviously, poorly named. It sets the return value. With me so far? Let's write some code because it'll be more obvious as we go along. And then so this I want to do. I don't want it. Is it type trait? Is it type trait? Basically, what I'm going to do is I'm going to write some tests, and I think this will all become obvious. Return third conditional t. If it's eager, then this should be a stud suspend always, otherwise it should be a suspend never, and then we're just going to return one of those. I think that'll work. Probably a type name in there somewhere. Yeah, so again, future plans is I envision the way of posting tasks also back to the main thread, so you can guarantee they run there. So the main thread is going to be synchronous in terms of what it does, but each step in the main, right, can farm out to basically threads, right? So it's scatter gather. So this is what we're going to start trying to build out today. Indeed. Okay, right. So all this does is conditional T is a type trait which basically says this will resolve to this type if this is true, and this type if this is false. So if it's eager, we'll get suspend always. If it's not an eager, we'll get suspend never, and we construct one, and then we get the auto type deduction. Bish, bash, bosh. So suspend always means, hey, oh wait a minute, I've got that the wrong way around, haven't I? Cool. Saved myself a bug there. If we're eager, we want to not be suspended and start executing until we suspend. If we are lazy, then we want to start when we're told to start. And then we're going to need I might just make this a struct. Do I care? Are people going to be dicking around with this? Do I care? Let's just make this a struct for now. We can improve the interface later, just only because this makes this bit a little bit easier. So the outer struct will want to own a coroutine handle, right, of a promise type, right? That's kind of how you bridge these two together. Okay. And then you've got auto get that. Hang on, I have to look it up. Can't remember. There's the last one, which is the weird one. Coroutine. Get value from promise, is it, or is that the helper? Is that the function you call inside it? Get return object. Get return object. And then this will obviously return a task stood coroutine handle promise type promise type from handle this. Okay. So this magical function here, this is the thing that gets called when your coroutine function needs to return something back to the caller, because it has to return a task, right? Or it will, for us, we'll have to return a task. So this will basically say, return the task, but stuff a handle to the special promise type and all the other bookkeeping stuff in the object first. So this is kind of how we bridge that back to it. Again, I'm hoping this will make sense when we get on to use it. So let's do using eager task equals task true, and using lazy task equals task false. So that gives us some nice aliases, right? So now we can just speak in terms of eager. So to the call side, when we're looking at this code, in like, I don't know, like 2 months' time, when we come back and we're like, what the hell is all this code doing? At least we can be like, oh, okay, fine. At least I know what the tasks are doing. Let's do tests task tests. That's fun to say. Let me show you how this works, because I think let me see if I can prove for myself that I know how this works. Okay. MNOPQ task test CP. Okay, cool. That fails, which is what we want. Can I gtest filter just run those tests. Okay, cool, right. So now we're here. So now we can do hash include concurrency task. Okay, so let's create auto eager int star x UFPS eager task. Right, so this is not a coroutine yet, okay, but now this is now coroutine. So as soon as you use co-return, co-await, or co-yield, it becomes a coroutine. No, I've used coroutines quite a lot before, so I'm hoping I can kind of breeze through some of this. But then I've also written thread pools before, and I made an absolute pig zero of that on Sunday, so we'll see. So let's do... Doesn't have to be a pointer, could be a reference. I've just arbitrarily chosen pointer. No name, right, so here's where we start getting the errors. No name initial suspend. What have I typoed? Initial suspend. No name from handle. So you sure? Oh, yeah, you're right. It's not. It's from promise. I get the handle from the promise. School error. I don't want to return type because I need it to be auto-deduced based on the evaluation of conditional T. Just check that builds and runs. Nailed it. Okay. And then auto. In fact, actually, this is going to be exactly the same. So lazy. So if we do an eager test, right? Equals int, right? If we do eager x, right, we should be able to assert equals x1. Okay, so this right, with this setup is no different to regular function, just with a load of bookkeeping under the hood, right? It eagerly starts it hits the coroutine and stops. Now the interesting thing is with lazy, if we do none of that. So if we do auto task equals lazy, right, this should still be 0. Are coroutines set up to return to the arg passed in or separate? So coroutines are set up to preserve the stack, right? So this, I guess, does that get preserved on the stack? I think it does because it's a local copy, right? So you can use out parameters. If you want to return stuff, the correct way is to co-return it, like for, and then have your task object modified to take that and then persist it within its promise. Nope, nothing crazy happened so far. Just talking about coroutines. So this should be 0, right? And then we should be able to do task.handle.resume, right? And now this should be 1. Because lazy should hit suspend always, which means it's suspended at the beginning. If this doesn't work, I'm going to look like such a mug, and it means I don't understand how coroutines work. That was a quick panic moment. Yeah, so this basically suspends it. So it basically means if in our now vernacular, a eager coroutine will keep going until it hits the first co statement, right? Whereas a lazy will always stop at the beginning and wait to be started. I don't know whether we're going to need that, but it's not a lot of work to have that, if that makes sense. I suspect we're mostly going to be using lazy because you want it to be scheduled on a thread. But if there's some initial setup that you kind of want to guarantee happen before it goes to the thread pool, then you could use eager. Eager means, yeah, start executing now in the current as if it was a regular function call. So transfer control flow from here in the current thread you're in to here, and keep going until basically we're going to do, eventually we'll have a co-await, right, which will suspend it. We're going to do some magic with co-await to make that go into a thread pool, right? Lazy means stop here and don't do anything, okay, until you've been resumed. Which, actually thinking about it, might be a little bit tricky, because how are we going to get that into the thread pool? We might only need eager. I need to consider that. We might have to modify some of this gubbins. Ooh, tricky. I hadn't considered that. Oh, well, let's leave that in there. Lazy might not work for us now that I've kind of puzzled it out a little bit further. But it's good to go through anyway. I think hopefully people kind of get a better understanding of how that works. Bran, hello, glad you're here. Ali, hello. Right. As always, I reserve the right to totally change what I'm doing. Yes, so, but we would have to, wouldn't you start lazy by suspend? No, lazy would be suspend always, right? Suspend never means don't suspend. Anyway, that's fine. Let's, what I want to do is I'm going to switch away from tests for a second, which is, I know, absolutely sacrilege, because I really want to try and get this working within the game, right? I really want to see something. I've got an idea in mind. I've got a vision for something coroutine to happen. So what I want, right, what I need is another manager. I think it's been a while since we've written a manager. Need another manager. We'll see. Will you see? Right. Awaitable is kind of the core machinery of what we want to do. So I think this all needs to be in one place. Otherwise, we're going to have potentially miserable globals that have to be passed everywhere. Useless middle manager. When was the last time I wrote a useless middle manager? Look, right. Managers are people too. Okay, awaitable manager. So this is going to glue all of our stuff together, right? This is about as far as I've thought, by the way. So so this is going to. I'm going to take a reference to a threat pool. Okay, so the awaitable manager, okay, is... I might make this header only just because most of the code is going to be templated or auto-variabled anyway. So at least this... I really need to do a code review of this and find out like where I've got header only code, where I haven't, where stuff can be context pro, where stuff can't. There's a big bit of work to be done there. Okay, cool. And then I guess thread pool by itself I think is non-copyable, but I think we should, just for our own sanity, make it non-copyable. It can't be copy assignable because it's a reference anyway, but I guess fine, like... I don't anticipating us moving it. Okay, right, so then... we're gonna need a way of awaiting on something, right? So, which then puts it into the thread pool. I wonder if it's better off writing the task I want to do first. Rather than going through all this. I wonder if it's better off. So what I want to do, okay? What I want to do is I want to have, so Awaitable is also going to allow us to do timers, right? And stuff that handles work continuously. So I'm actually going to do that first. Before I do the scatter gather, I think it's easier to do like timers and more basic awaitable. So like basically await for the next frame or await for some number of nanoseconds. Those are the two things that ideally today I want us to be able to have code where we can await for the next frame, okay? And await on a timer. Those are the two things. And might be wondering like, no, implicit destructor here is fine. Why might we want to schedule something on the next frame? Because coroutines can be suspended, they can effectively sit in an infinite loop, right? So we can have some periodic logic that goes in an infinite loop and it always schedules itself for the next frame, okay? Which means, like, what I want to do is I want to have a flashing light, right? I know it's not particularly exciting, but I want to have a light that pulses, but I want to do it entirely in a coroutine, because I think once we see that, I think that will start showcasing, like, the power of what we want to do. So if we go to main, right? Hash include concurrency thread pool hash include concurrency task hash include concurrency awaitable manager. All right. So let's do where we do all the setup, right? Oh man, so there's a lot of code in here now. This all needs to be pulled out at some point and be made a little bit nicer as well, but c'est la vie. Let's get rid of some of this crap. Okay. Oh, that's his comment. I must re-enable that at some point. Keep an eye out. I will re-enable that soon. Okay. So just after we do all the setup, right? Actually, where do we do all the other manager guff? Mesh manager, text manager. Right, so let's do auto pool equals UFPS. So let's create our thread pool, right? And then let's do auto awaitable manager equals UFPS awaitable manager pool. Okay, right? Nothing too drastic so far. Because I kind of have a vision for how I want the coroutines to work. It doesn't mean that I'm right, and it doesn't mean that there aren't better ways of doing it. I just want to I want to go through my initial thought process first, and then we can always look at refactoring it later. So let's do auto pulse light. Okay, this is going to take a UFPS point light. Light, and let's do UFPS. Let's do this first, actually. UFPS awaitable manager AM. So I'm not typing awaitable manager every time. Let's just call it awaitable, and this is going to return UFPS eager task. Okay, so eager task. So this is going to start executing straight away, right? So what I want to do is do for infinite loop, right? Obviously, we're going to need some way of actually we might not need a way of signaling these to stop, because Coroutines kind of handles that for us. Textures and images are just going to be, they just get hash embedded into the binary. Okay, so what we're going to do, so all the stack variables we have remain valid, right? So we've got the light. So what I want to do is do like float fake time. Right. We've got to handle delta time at some point as well, but let's do fake time. So let's do light intensity equals stood sign of fake time, right? And then we'll do fake time plus equals 0.01f, right? So again, this is going to make the obviously it's going to go below -1, so we could just actually just then want to do what plus 0.5f, is that right? Will that always make it above? No. +1, and then over 0.5. Over 2, half it. Yeah, I want it to be between 0 and 1, up and down, right? Over some fake time. So infinite loop, bad, hot take. However, co-await, awaitable, right? This magic will now happen, okay? This will suspend it. It will then go to it will then get pushed to the thread pool. The thread pool will no, this will then go to a task queue, which we'll have to have separately. The task queue will then resume it on a thread. This will then go back round again on that thread and schedule it back on the queue, but the queue on the next frame will then push it to the thread. Right, I think that's right. So basically this is it. And then this, right, if this, let's be confident, when this works, stuff like this, I think, is a really nice way of handling interesting game logic, right? Because now we don't have to have a massive state machine. We don't have to worry about kind of like once all the delta times and stuff are sorted out, we don't have to worry about adding like loads and loads of like, you know, at the beginning of this tip, do this. We should be able to just set up all these functions once, and they will just keep running auto scheduling themselves for us. Right, so that's the vision. So how does one await, right? Co-await is an operator, okay? So by adding the co-await operator to our thing, we can co-await on it, okay? Animations. I've got some great plans for this. I think we can nail this, right? You can play this clip back later, and in 2 months' time when I've thrown it all in the bin, I really think this is going to make our lives a lot easier. Okay, right. So we got co-await. So this will now be called for us, right? By this. This has to return an awaitable, okay? It does not have to be called awaitable. In fact, it's not even called awaitable. Awaitable, right? You can call it whatever you want, as long as it has 3 magic functions. Auto initial suspend. Auto. No, wait a minute. Sorry. Await initial. Await suspend. Auto await resume. I think. Let me just check that. I do have the await ready. Await red. Is it await ready? Yeah, await ready. Right. Okay. Of course. Turn false, and I'll explain why in a minute because it will make a lot of sense. Right. Okay, right. So okay. So this is a magical struct, which again has customization points for the state machine. The state machine, when you want to co-await on something, that basically means putting it in a suspended state until something in the future resumes it. What resumes it, you ask? Well, that's for us to figure out because it's all customizable. await when you co-await on something, it goes through a journey. Okay, the first journey it goes on to is await ready, and it basically says, do you actually want to await? This is an optimization function, right? This basically says if I'm going to be awaiting on some IO, something to happen, if I have guilty knowledge, right, and I know that the thing that's going to happen has already happened, I can await true, and it will not go through all the suspension logic, which has a small cost, right? So this basically is like, you've asked me to await. Do we definitely want to await? Okay, cool. Await suspend is the thing that gets called when the coroutine is actually suspended, and it will pass in the coroutine handle, the opaque handle, to the suspended task. So this is how we effectively tie up task to the awaitable, right? That coroutine handle object that comes in here, which allows us to, I don't know, store it somewhere for putting in a thread. And then await resume is what's called when you finally resume it, which allows you to do extra stuff here. I don't think we'll need to do anything here, but we might want to do some logging or some timing, like profiling in the future. If we want to be like, hey, you know, the average time something was awaited for was whatever. I don't know. But you have to have it. So what we want now, basically, I think, is we basically want, we need to persist this handle somewhere to be stored later. Okay, so let's do, and this is why I wanted to build out these primitives. Let's have a concurrent queue. Okay, concurrent queue of the coroutine handles. Okay, and let's call this this is the next tick queue. Okay. Everyone with me so far? So we have access to the andl. Now, of course, the question is, I'm within. I can't just do next tick queue dot push h, right? Because next tick queue doesn't exist in an awaitable. But you have to remember that this internal struct is effectively an implicit friend of the outer struct. So what we can do is we can have awaitable manager am, right? And then we can pass in this, right? Actually, I'm going to call this self. And then we can do self.push.h. Why is it not like that? Cannot bind to... Okay. Can't bind that. Strange. I must have a bug with my concurrent queue because coroutine handles are copyable as far as I'm aware. But yeah, so basically now, every time we co-await, this will go into the queue for executing later, okay? And now what we can have is we can have auto process queue, queue, void, right? And then we can do, concurrent queue. Let's do auto yield. Do I want to force this to be a vector for easy iteration, or am I just going to preserve? Let's just preserve the type for now. But we might want to optimize this. We want this better later. So let's do auto queue, queue equals queue. So let's get an empty queue. I already regret using the single letter queue, but hey ho. And then let's do auto lock equals that. Let's scope this. So we're going to do stud ranges swap q and q. And then we're going to do size equals 0 u. And then we'll do q dot, we'll do stud range. Is that going to work for us, actually? Can I just... Yeah, and then do... Yeah, sorry. Yeah. Size equals 0 u. And then return q. Right, so create an empty queue, lock the existing queue, swap it with the empty one. Okay, so at this point, and this is just going to be, it's a deck under the hood, so it's just a handful of pointers, right? Over. This is pretty much free, okay, or at least considerably less expensive than taking the lock. Reset the size and then return queue. I'm hoping we get NRVO here. Can't guarantee it, but we'll hope for the best. But this is basically going to yield up the queue, so which means now I am the owner. I've transferred the entire contents of the queue out. So anyone now pushing to this current queue is going to be pushing to the next one for the next frame. Will you get RVO with NRVO? Well, you won't get RVO because it's named. Would you get NRVO with a lock? It depends whether it's clever enough to use the address space of the return value, where it's clever enough to use the stack space of the calling function, right? Probably not. Either way, it'll move construct it right out. So I think it'll be cheap. I don't think we'll be paying for a copy of every single item, basically. So now what we can do is we can do const auto to process equals next tick q dot yield, right? Okay, this will give us that, and then we can go for const auto handle. Yeah, exactly. Yeah, a deck is a deck. Well, a vector is 3 pointers. What's a deck? I suppose it's a little bit more. Is it just 1 pointer? No, it can't be. It might be 3 because you've got the. It's got the effectively the double hop, hasn't it, to make the deck work. Anyway, whatever it is. For const auto handle into process, right? We can now do pool dot add handle, hoping the copy will work there. Handle dot resume. You can't iterate through it, can you? Fine. Handle equals the move to process dot front to process dot pop. Right, there you go. So hopefully that kind of makes sense now. The awaitables will be pushing these to a queue, and then once per frame, we're going to be like, process this queue, okay? And then that is going to go through each of them and farm them out to the threads. Obviously, this could be optimized. This is going to take, if there's like 1,000 handles in there, which I think is fine. Like, I think you could be processing thousands of coroutines. Handle, I think handle is cheap to copy, right? I mean, if we're worried, we could do stud move handle, right? I'd have to check. I think handle is basically free to copy. So I think it's fine. Just done it here just out of habit. This is going to take a lock every single time, so you're going to be hammering that lock. So what we would probably want to do is convert this to a vector and then have pull add range or something like that, which will take the lock once, push them all into there, and then resume. But for now, like, I think this is, let's keep it simple, right? I think someone even mentioned that when we did the thread pull. Are people seeing the vision yet? Let's see if this works. So let's do UFPS vlog. Actually, no, I don't even need to log it. Like, this will either work or it won't, right? So at this point, the scene would have been fully constructed. So before we start running, we will call Pulse Light with the Awaitable manager, and then let's do the address of. You probably could do this with references. I don't know why I didn't, but I guess that's more my problem than yours. Lights. No, get the first light. Can't remember. I get the lights now. Get light data. Okay, fine. So that's light data dot light 0. Again, we don't need to capture the return object of pulse light because the awaitable will automatically, because we're passing in await manager, that will automatically persist it for us. In fact, we don't want to manually resume it. So in theory, right, that's going to start pushing stuff into threads. So we're going to pump the events, we're going to translate the camera, and then actually, so before we do any of that, so what we'll do is we'll do awaitable manager dot process queue, and then we'll do pull dot drain. What could go wrong? I mean, it builds, which is absolutely terrifying. Oh, damn it. Why does it want another declaration? I haven't declared all these, have I? Why is it like... No, missing declaration. It's not a warning I particularly care about that. Let's go rebuild loads. I mean, if it works though, but if it works though. I don't know where light 0 is. Is it the red one? Oh, it is. Look, it's really slow, but it's doing it. We need to make that. We need to make that much faster. Oh, it crashed. Oh, I've crashed. Okay, so I can't exit the game. But we can fix that later. What happens if I want it to go... I probably want it to go higher, right? Do I want it to go faster, or do I want it to go... Do I want the value to go... Let's make it to go faster. Between 0 and 1. That is going to absolutely pig to track down now. I have no idea where that's happening. It feels like a deadlock. I'll just attach debugger and pause it. And we'll talk about it. Be easy. Pish bash bosh. Those value changes are tiny. I need it to be much bigger. Oh yeah, I forgot I can't quit. I can't do maths. What if I want it to go between 0 and 6? Do I then yeah, I then do, so let's do 10.0 f times that. Yeah. Oh, like, I mean, if that works though, like, I don't know. I mean, that's pretty sweet, right? It's like what, 5, 6 lines of code, like on the user side, and we've got an infinitely pulsing light. And that is running across different threads. That is hopping between threads, right? That is whichever thread is able to pick it up, it's picking up. So if we added more, like we could fill all those threads. Like I'm pretty pleased with that. And I think like coroutines are pretty efficient, right? So I think we could have like thousands of coroutines going. We would probably have to write a custom allocator for it because they do heap allocate, but we have full control over that if we need it. So we could probably have a per thread linear allocator or something. Some people might call that an arena. I probably wouldn't. But yeah, pretty cool, right? Pretty cool. What happens if we... Okay, before I fix this... I knew it. What happens if we do... Like, can we get like a party mode going? Can we just pulse the lights to random RGB? Why is that not? Why are they all changing the same? Oh, because I need to... they all need some offset, don't they? Well, R is already 1 because it's red, but this normalizes them. There's no differentiator between here. I don't want to vary the fake time. Like, they all just need to have some... Also, they don't need the 10x, right, do they? Because this is just RGB. So don't they just need some... like, known offset? Yeah, phase offset. That's what I want. So is that sine fake time plus 0.1? Like this. And then I just do, like... something like that. I just want to see if I have a party light. Yeah, all the threads fight, and then there's only one left, and then that gets to be the main thread. That's how all processes start. Of course, it goes down to... it will always pulse to black, won't it? So there's obviously better ways of doing it, but I don't know. It's pretty... There's no other differentiator, but like... I don't know. That sounds pretty cool. Like, you can see the luminance histogram kind of breathing with it. Okay, fine. Right, let's fix this deadlock. Revert this. I don't know, I'm pretty pleased with that. Like, I've been thinking about this since Sunday, right? Like, it's been taking up a non-trivial amount of space in my head, and I was thinking, I really want to do something with cool coroutines. I really want to farm out to threads. I really want to have tight little function blobs that I can just spin up and just automatically schedule themselves. And that kind of just worked. Yeah, exactly. But like, let's. I think this is fine for now. Okay. Let's break out the debugger and find out what it's doing. Let's debug it. So it might be, I don't know, there's lots of things. We do need a way of cancelling the task. Well, no, because the task, that's a good point, because the task will always reschedule itself, right? That coroutine handle is basically going to go in and out of that thread pool. So we do need a way of cancelling it. Probably when... Actually, hang on. Let's just see if I can figure this out before I go to debugger. Let's... Awaitable manager. Sure, someone said, don't you need a custom destructor? I was like, no. Let's take this and to process dot front dot destroy. So you can destroy a suspended coroutine, and that will just release all the heap allocated memory for all the stack and kind of clean it all up. Obviously, it is then UB to resume it, but this is the destructor of Awaitable manager. So is this... Oh yeah, be right. I'm going to need to be able to trigger this when I signal the exit. Aren't I? Because I'm never getting to the destructor, am I? I don't know, let's just see what happens. Okay, fine. Maybe I will use the debugger. Hey, something along these lines. Something is probably stuck in a queue somewhere. I've thrown an exception already, but I don't know. Certainly wasn't the one I was expecting. That's grim. This feels like old code. Where am I? Oh, I'm in the wrong one. That's why. Fine? Question mark? Home me projects offs select. Nope. Right, let's try that again, shall we? Okay. So we've got a pulsing light. Where I do have an exception on a thread. God, so many threads. Not what I was expecting. So I've clearly... push the worker back. Stop token has been signaled because it's the only way it's going to break out of here. I've segfaulted. I don't think it's to do with exceptions because we're not throwing anything, right? It's a seg fault. This is weird. Is this like a static initialization fiasco? Because look, we're coming out the end of this thread, right? Which main is, I think main is gone, right? Main is fucked off, right? Which means we are past the end of main. We are killing the threads. I posit this could be part of the static initialization deinitialization fiasco, which is basically where it's very hard to reason about the order of construction and destruction of static objects. And if they have interdependencies, then you often have problems. I wonder. Let's try getting that under a bit more control. At the very least, we should be able to control that a little bit better with pull equals stud make unique. All right, and then nice by make unique. Then I don't think pull is then used to, and then we do pull dot drain, and then oh no, that's on the stack, isn't it? So that shouldn't. No, that's it's not. Pull isn't a static, is it? And these get destructed in reverse order, so this will get destructed before this. Why is? Because this should wait for them all to join afterwards. So we could do thread dot join, but I don't think that's going to help. Oh, in fact, I can't because I don't. It's not part of my API. Oh, funsies! It's can never be easy, can it? Yeah, but like I want to understand why this is happening. Like, why is it? It doesn't help that main is gone. Do I have any logs from this? Look at this stopping, right? Main stopping, and then ending worker. Some of them. So why would some of them be fine and some of them not? Let's do log info stopping thread. All right. Oh, do I not have a formatter for thread? Interesting. That's what I did. Yeah, I do. Oh, but I don't have a formatter included. There you go. Well, the coroutines and threads are kind of a somewhat orthogonal concepts, right? But each stack will have its own frame, yeah, and each coroutine will have a heap allocated frame for the coroutine. I don't think it's an exception. Oh, race condition is printing out. There's a race. I bet it's printing out, causing something to slow down. I bloody love it when a print statement fixes a race condition. JThread calls join by itself on destruction, so that's fine. And the work threads. I bet I know. Actually, I think I might have an idea. Actually, I bet. I'm going to be saying that a lot. I wonder if we should wait for them to drain first. Yes, I bet what's happening is this is being destructed, which is oh no, it says thread safe queue. I'm wondering. I wonder if I just need to wait for everything to finish. This won't be a particularly satisfying ending. Why do I need to make sure jobs are finished first as well? Yeah, main's just all local variables. Well, so that's a great question. Like, is the queue signaling threads to end and not waiting for them? JThread is an RAI primitive which calls join on its destructor, and as the thread pool owns the threads, when the rest of the thread pool destructor runs, it will run the destructor of the vector of threads, and that in turn will call join. A local define main, you're killing main first. No, I don't think so. Like, main will end when main ends, right? And you don't return from main, so main still exists. No. Like, main certainly ends. Main ends here, right? Why? So this will request that they all stop, right? And then workers, which is a vector of threads, right, will call join. That's fine. What I could do with knowing is like that gets signaled. That wakes this up. That breaks. Is there a job still in the queue? No, because we call drain before we return. Can we try giving all threads a job to run, then just adding 2 numbers and does nothing to see if it works then? Yes. By adding 2 numbers together, do you mean independently? The problem is, I think it's timing issue. So by the time you log it and stuff, I'm worried that. And also, do you mean via the coroutine job or just a task? Like, just give it a job. Where do you mean? So like here. What do you want your job to do? Give it to a weirdly partialist, I state. Oh, I see what you mean. I don't think that's the case, but let's do stood this thread sleep for 500 millions. So that will make sure that they all get picked up by a separate thread. I mean, they use stop tokens, right? So they that's how you signal they've ended, and we signal them to end. No, it's definitely non-deterministic how many threads get called. But what I don't understand is why there's a seg fault in running. Like, let me just. Problem is that if logging changes it, this is gonna be an absolute pig. Well, but the pool is what tells the threads to destruct, right? So the threads will only destruct once triggered from the pool destructor. I'm thinking what we need to do is take the task out. Yeah, stopping threads, right? Okay, let's work this back. So let's not add a task, but let's still continue to pump and drain. I guess, yeah, I see what you mean. That probably should be called pump. We'll change it later. I just want to get it working first. I wonder if we can construct this under a unit test to fail. But does triggered thread try and remove itself from the pool? No, the thread has no knowledge. The thread primitive has no knowledge it's in a pool. It just wraps jthread. Okay, so that works. So it's something to do with us putting a task. So something to do with the awaitable? Let's have a look at this. And that. No, the infinite for loop's fine because this will cancel it because they'll be in a suspended state. Is it trying to no? Because the way the destructor works, right, is the destructor for the member variables, aka the vector holding the thread, will happen after the custom destructor for thread pool, right? So I think that lifetime's pretty well managed. It's something to do with this, and I don't sure I understand why. We're gonna like. I'm gonna try this. It shouldn't need to do any thread suspension for this. Like it should. Join will effectively suspend the thread until it's done. So join will block and wait for the thread to finish, but we've issued the stop token. So that should be fine. Okay, fine. So it's definitely something to do with it being put into the thread pool. I'm pretty sure I can copy coroutine handle. Because it's passed in by value here, right? What does the docs say? Custom coroutine refer to a suspended or executed coroutine. Every specialized coroutine is a literal type. So it's a literal type. So it's a literal type. It's a concept that can be constructed, manipulated, and returned from concept functions. Any of the following: scalar type, reference type, So it suggests that it can be copied, right? So if we look at the constructor, I assume it has a copy constructor, right? 3.4 copies the underlying address. The copy constructor is equivalent to implicitly declared ones. Okay, which basically means it's copyable and movable. But I move it. Where do I move it? Yeah, I think that's just to do my terrible interface for push. It shouldn't make a difference, right? I suppose we could go and have a look at why that is. Why can't I bind to an L value? What have I declared push as? That's a forwarding reference. I don't understand why that doesn't accept that. I'm pretty sure it's still a forwarding reference, even if it's a class template. Cannot bind an R value reference to L value. But where do you think I'm doing that? Why does it think this is an R value reference? It's not, it's a forwarding reference. Maybe? I don't think so, because I don't think there's any way I could construct this such that this wouldn't work, because I forward it here anyway, right? I mean, I could take it by value and then move it in, right? I don't think that would be kind of equivalent. It wouldn't preserve the R value, the value category, but I think that would then make this move more salient. More explicit message. I don't know. We'll have to try in a minute. The thing is, though, is that a forwarding reference will deduce to the value category that was passed into it, so it will preserve it, basically. So it looks like an R value reference, but because it's templated, it means the value category, it means it'll be an L value reference if you pass in an L value, or it'll be an R value reference if you pass in an R value. Sorry, it will deduce the value type based on the value category of the thing you put in. But look, it's pulsing, it's executing, right? So it's definitely, like, it's definitely going into the queue. This is what I don't understand, right? It's definitely being executed. Leave that as and fix that later. Can I do... sure. But again, it's going into it. So it's going through the loop fine. We could, yeah, we might need to put a breakpoint. Yeah, I think that might make sense. Yeah, okay, fine. Let's stop guessing. Let's put a breakpoint on the end of main, right? So we can inspect the state of everything just before it goes out of scope. And then let's do thread.h. I don't have the destructor, but we can... I guess we could set a breakpoint here, because this will be when this will be called when the worker ends, right? Because the worker end comes out of here. Let's try that and see what it gets us. I need to move this way so I can get access to the window. Yeah, I think we just have to. I think we're just gonna be debugging this. Oh, so I really wanted to do the timer queue. I could do it and then fix this bug later, but hey ho. Right. So the first thing that happens is this is returned. We still have all of our threads, right? All of our threads still in flight. I think they're probably all. they're probably all in a waiting state, right? So let's have a look at. You're not going to give me any local variables. That's rude. I don't want a Copilot summary. Piss off. I want to know where my variables are. Ah, here you go. Skill issue. Right. Pool. 15 workers. I seem to have a lot more threads than workers, question mark. Unless something else has been injecting threads into my process, which is very possible. Ah, look, what is all this bullshit here? I bet those have been injected in. Right, this is waiting on the worker, right? So this is here waiting. These all are waiting to be told to stop, okay? That is fine. So as we could set a breakpoint here. The default was no, it clamps it between 2 and 32 based on hardware. That is suspicious, though. Is my logic wrong? This should clamp this between 1 and 32. But no, because worker count is thread pool. This worker count is 15. It is suspicious that it's 32 though. But anyway, I probably got something running my system that's injecting rando threads into stuff. Job count is 0. There are 0 jobs in the queue. So what if we... There should be no issue with stack corruption on coroutines if you use them normally, right? It's all handled for you under the hood. The only thing that adds workers to the pool is this constructor here, and you tell it how many to give it, right? I suppose we could just override this and just see what happens. But it doesn't matter, to be honest, it doesn't actually matter, right? You could have 1,000 threads and they would just be context switching. It doesn't actually matter how many threads you've got. Okay, the actual number of threads is actually irrelevant. I think... So there's 0 jobs, right? So if we... So main is about to go out of scope. Okay, so if we go forward, this thread has now been woken up, right? I think. But I've lost the main thread. So why... Oh no, wait a minute, here you go. Yeah, main is... Well, I'm a little bit... Here you go. What's it? Oh, here you go. Main. Fuck's sake. Thread pool. Requested stop. Okay. Called request stop. Stopping threads. Am I deadlocked? Trixie, 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 Trixie. Well, they have, right? The main doesn't return because it processes the queue and drains it, right? So this literally, there is literally nothing going on here. If I pause the main, I think this is hosed. These are all running. There's something weird's going on here. All right, let's start again. There are no threads. Sorry, there are no tasks. There's a weird lifetime issue somewhere though, right? Because I think it's a... What the fuck is JIT injecting into my process? Where did my thread start? I suppose it's going to start around here, isn't it? It's 32 minus 16, whatever it was. Yeah, but the coroutines, the vision is the coroutines are completely agnostic to the fact that they're running on threads. They shouldn't care. They shouldn't be doing counting or waiting or anything like that. Looks to me like the thread pool detour runs faster than stopping the actual threads. Main ends, but main can't end, right? That can't be true because main is a stack variable on. Main is a stack variable, right? Sorry, blech. Take that back. Start again. Don't know what I'm talking about. Pool is a stack variable in main, right? So on this line here, 505, this will initiate the local destructors of all the stack allocated objects in reverse order. It will destruct the awaitables, then it will destruct the thread pool. Okay, so the thread pool will not, main will not finish until the thread pool destructor has finished, right? At which point all the statics step in. So I really just. Yeah, it's something to do with the state here. I get a fresh stop token. So that's not. Well, stop token's reference counted anyway. But the detour does not. Right, yeah, so I think this is. Yes, so let me just double check this because I think a few people have said this, right? If you look at threadpool.h, right? Okay, threadpool.h owns a vector of thread objects. So when this destructor is called, after this will reverse destruct all of its member functions. So main calls this, which in then turn destructs this, it destructs this, this, and then this. Is it an order issue here? Am I destructing the job queue before the workers are being destroyed? That's the same issue. I think it's got to be something around this. There's no statics around going on this. I feel like I've got a destructuring order issue, so. Oh, I really thought that was it. We'll figure this out. We'll figure this out. Do we need to clear the job queue? I don't see why we would have to. Okay. We could do it. Where would you want to do it? Before or after? Shouldn't actually matter. Because this will always break out of here, right? What's it called? Job. That will effectively drain it, right? It gets through like a few. I think I need to see this segfault again because there's clearly these breakpoints. And run it. Worker CV. Ooh. Are we destroying this? Yeah, what happens if we... Once we explicitly unload them here before all the member variables start getting destructed, that will tell us if it's an ordering issue. I think the theorist might have it. I want to fix that. So workers should be destructed absolutely last. No, sorry, workers should be destroyed absolutely first because that will force them to join whilst everything is still live. So workers should come down here and then get rid of this. I don't really like having public functions which influence the internal lifetimes of stuff because it's not what there's nothing to stop someone calling end right away, right? The destructor is there for cleanup, and we should make the destructor work. Yeah, okay, I think that's it. Whew. One more punt. Good spot. Good spot. This feels like a commit. Task and add task tests. Add task and tests. Add yield to concurrent queue. Oh, didn't we say we wanted to rename something? We wanted this to be pump. So let's see. Fix race condition in thread. Oh. Remove annoying warning. Add awaitable manager coroutine light pulse. Update scene. Right. Let's start the groundwork. 20 minutes. Let's see if we can do a timer queue. I might as well leave those in there. I don't think there's anything bad about that. Okay, let's do Awaitable Manager. So what I want now is let's do hash include queue hash include chrono. Right. I want to concurrent queue struct timer awaitable stood chrono steady clock time point stood coroutine handle, right? So what I want now, and this is why I think this is why I, in my mind, started thinking about extra templatey stuff. I want a timer awaitable, and then I want a stood priority queue, right? Timer awaitable. Timer queue. So the idea being that we will put stuff in this queue with some time point in the future, but the priority queue will keep it sorted for us. So we can keep just popping off the front, right, until a timer is beyond us, at which point we know we've processed all the timer queues. So we don't have to iterate through all of them. We just have to iterate up to some point in the future. I think our concurrent queue interface might be a little bit clunky for this, but I'm sure we'll figure it out. Now, here's the question. Priority queue, which way does it order? It provides constant time lookup of the largest. I want smallest. So that's going to be stood using timer from, okay, Twitch is there. YouTube, is anyone there? Hello? Twitch is here. YouTube, hello? Oh no. It's not looking good. Apparently I'm still live. Okay. Whew. Right. Let's do time priority queue equals stood priority queue timer awaitable stood vector timer awaitable and then stood greater timer awaitable. And then this should just be a queue of time priority queue. Okay, and then this means this will need a auto operator greater than const timer awaitable other const bool return time point is less than other dot time point, right? So I think that will now order stuff as a min heap rather than a max heap. So then we're gonna need. Can you do auto co operator co await stood chrono. You just do stood now. Wait time. Co is a unary operator. doesn't matter, right? As long as we return an awaitable. So I think I can just do this, right? Doesn't matter as long as I get the awaitable, and then we're basically going to yoink all this. Stick this here, and then this is going to go push timer queue dot push stood chrono steady clock now plus wait time h dot time point equals dot handle equals h. I can't. So annoying. Got to do the same stupid bounce thing. All right. I thought steady clock was nanos. Unless this is, what is this? Is this? Oh, it's something different. Okay, fine. Is that, oh, is that just the ratio not wrapped up in a time? That's fine. That'll work. There you go. Okay, stick a comma there, so this formats itself in a slightly easier to read method. Right, okay, so when we await on a duration, right, so this is really nice. We can basically say, wait for me 1 second, wait for me some number of nanoseconds. We can go into the timer queue, and then this will pump it. So what we can do now in pump, we can basically say... for no, let's do auto auto timer awaitable equals timer queue dot front. Okay, so that will pop it off, right? It's gonna be a little bit gross. I think we might be able to make this a bit nicer. Basically, if timer awaitable dot time point is greater or equal to stood chrono steady clock now, right? So if the time has elapsed, then do this, right? Else timer queue dot push. We have to push it back, which is a bit lame. There's no like peak. I suppose because it's lock free. There's not really a lot you can do. In fact, actually, this should be while. Wow, that's going to be really grim. What happens if the queue is empty? I don't think it matters. We could do. I just wanted to make sure that I don't accidentally, whilst not timer queue dot empty. Okay, I'm spending an awfully long time if that queue is empty. Front pops for us in our queue because there's no way really. So the reason queue and stack have pop separate to top and front, right? The reason that front and top don't remove the object is because it's impossible to maintain the strong exception guarantee with those. However, like when we're locking in everything, we don't really have a choice. We have to lock it and take it off and return it. So You're right. That could be a while. Is next tick queue not the same? No, because what we've done here, when we've yielded out the underlying queue, so this at this point, this is now a stood queue, which means we do have to pop it. Whereas here, we're not yielding it; we're actually just using the top level concurrent interface. So remember, you have to remember yield. We had this discussion, right? Concurrent queue yield returns a type queue, right, which is the templated type up here. So it's stood queue. Like, I don't... Get rid of that. Is that what we need? Like, is that all we need to do some timers? Because everything else is all wrapped up in the existing Awaitable Manager interface. So here's a fun one we can try. Where's pulse? So let's try auto flicker light. All right, FPS, Awaitable Manager, Awaitable, UFPS, light, UFPS, eager task. All right. So let's do forever. Going a lot of infinite loops in this code, right? Let's do awaitable 1 second, right? So the first thing we're going to do is we're just going to suspend ourselves for 1 second, okay? Then let's do light intensity equals 0.0 f, right? And then wait for 100 milliseconds, right? And then let's set the intensity to like 5, okay? So this is gonna wait for a second, set it to 0, wait for 100 milliseconds, then set it back and then wait for a second. So this should be on for a second, off for 0.1 of a second, right? If this works, this is a really nice interface. Because you manage just setting all these up at the beginning of the level, right? Problem is, I don't know where any of my lights are. So red is 1, green, red is 0, green is 1. So I think I want like 2. I think this might be the one above the generator. Yeah, or in future, like attach a script or something which just drives through our coroutine system. Like, there's loads of opportunities. Oh, god damn it. What are you chatting about? Nothing's ever easy. What does it not like about that? Do I have to move it out? I mean, it's a PR value, right? So I shouldn't have to... That seems strange. Moving a temporary object prevents copy elision. But yeah, well, I don't want that because it's a temporary object, right? Yeah, so that is right. So why is it not like the... Error. Has no member named front. Whoa, does priority queue not have the same interface as queue? Oh, it's top. Oh, what a fucking nightmare that is. No. Right. Templates it is. Concurrent queue. Right. So let's do auto. Hang on. I think there might be an easy way of doing this. What am I thinking? It's this, isn't it? So let's do requires TT. Hang on, let's do this proper way. Concept can pop. Sorry, can front equals requires t. Hang on. T dot front. Whoa. What is going on? Am I having a stroke? Oh, I've got caps lock on, that's why. Write that again, shall I? Requires can pop. Can front queue. What is better, using one global namespace? Okay, so using global namespace directory, for example. Really up to you. Like, namespaces are there to remove ambiguity and to avoid name collision. So again, as I'm not shipping this as a library, it kind of makes sense to me just to stick everything together. If you think there is value, for instance, if you're carving your code up into multiple libraries that might ship separately, there might be advantage to it. Personally, for me, I just tend to keep it as one namespace unless, like, very specific situations. Like, what do we do? Was it the reflection stuff, like the serialization stuff? So I have UFPS : serializer : YAML, for example. So it's really up to you in the situation you need. Personally, I just stick everything in one namespace. Oh, I forgot to close my import. Oh, now these need to be import, don't they? Oof. Why is it ambiguous? Surely it should Surely should only match one of them. Where have I templated wrong? Is it because it's not a dependent type on the... Q got both front and pop. Oh god, it does as well. Right, fine. Which is the mother? So it's, I only really need to. Yeah. So what I want concept can pop, can't front equals can front can pop T and not can front T, and then this should be can pop can't front. Absolutely outrageous. Oh god damn it. Right. Invalid use of void expression. Oh, because this should now be. Oh, do I want? I don't want. I want can. It's not pop. It's top. Which is kind of. I don't know if I want to be asking if you can top, but here we are. Because of course they both have pop. Just my sanity slowly being laid out in increasingly verbose concepts. Of course, pop is obviously they both have pop. Right, which light is flickering? And also, it's certainly not waiting 1 second. Is it this one? I'd like to know which light is absolutely, like, it's this one, isn't it? Yeah. Okay, why is that? You can see the vision though, right? Oh, lol. Still not there. Have I got something else? So that should be that, and then yes, you're right, it should be that. Yeah, I'll tidy up later. I just wanted to kind of get that working. That's cool, right? That's cool. That's cool. Which bug? What bug have I got? I'm running a high now. Look at this. This is great. Why are you talking about? Don't talk about bugs. In the top template. We just acknowledge that this is pretty cool. Thank you. That's what I'm looking for. Right, now tell me where my bug is. Here. Ice cold. Oh, I fixed it. You see? So yeah, I think like this I think is really nice architecture now, because you can imagine, right? We can await on anything right? If we had asset streaming, we could await for something to be loaded from the disk. Obviously, we don't have that, we don't need it, but we could be awaiting that. We could await for, I don't know, a certain amount of time. We could await for collisions, right? Anything the system can kind of check against, we could await for triggers. So could you imagine having like a door lock function and it just perfectly suspended until the player walks over a certain thing, and then it triggers a door to close and then spawns an enemy and spins the fan and flashes the lights. Like, we could await on that. We could just keep adding more things to await on as the game gets more and more complex, right? Which I think is really powerful. I think it'd be really nice to be like, yeah, wait here, wait for this to happen, spawn an enemy, flicker a light, play a sound, do whatever. If you're getting an ad, or you on Twitch, I mean, you can always use your if you've got Prime subscription. I'm just saying. I don't know if like this is kind of impressive. Do we think this was impressive? I don't know. Is there any, sorry, no. I'm sorry. This is impressive. Is there anything else we could do? Oh, sorry. I look at the time. Okay, no. I'm going to leave it here. I'm going to end on a high. I think this is cool. I'm really pleased we got this working. We fixed a nice bug. Well, we fixed a miserable bug. A job's cancelable. Yes, as in you can cancel you can destroy the handle, and if they're suspended, that's absolutely fine. However, there is no mechanism through which to do this at the moment. We would need to return something that would allow us to do it. I've got no beers at the moment. Sad face. I'm trying to cutting down a bit, so I'll have to wait till the weekend. But yeah, like that is I'm genuinely pleased with that. This is, man, I've been riding real high on this project recently. Like, we got the reflection stuff done, which was pretty sweet. Got some threading stuff done, the coroutine stuff. I think now, like, now that we've got these kind of things in, I think we're gonna have to. I don't think we have any like excuse not to tackle physics engine now. Like, I think that's the next big feature. Right? Like, kind of proved out the coroutine stuff. Like, it could always be improved and worked on, but I think now that we've got these, now that we can schedule jobs and wait for them and do timers and stuff, we probably do need to do scatter gather. Actually, I think we should probably add the last. So what the last thing I do want to wait on. So I think this might be Sunday's job. Is have so we can await. I don't know if I might change that to the call operator so it's consistent. Anyway, so we can just await on the awaitable, which means put me on the next frame, right? We can await on some number of nanoseconds in the future. What I also want to be able to do is await for some number of other tasks, other coroutines. Yeah, me and Chono had a chat, and I code reviewed his game engine, and he had a fun thread bug as well. Yeah, well, I think it's so. I think Matthias has got such a great point here. Like, the fact that after we set up all this infrastructure, we added timer queues, right, in like 30 minutes, right? Obviously, had some templating bugs, and whatever, but like we added the ability to wait an arbitrary amount of time into the game with a nice interface in 30 minutes. So that I think the next thing to do is probably do a waitable on a vector or a span of other tasks, and then we'll need some sort of latch so that we can make sure that once they're all done, the final one gets resumed. I think there's a little bit more mechanics there. I should probably write some tests for this. I might do the tests off stream. I don't think they're particularly that interesting. I just want them more there for debugging and regression. Let me start committing this up anyway, whilst I'm just sort of waffling. Allow other QUEUE types in concurrent queue. Await on timer. Flicker light. So, what stream are we on? Stream 28. So I'm not going to merge this yet because I think Sunday. Okay, tell you what. Let's on Sunday. Let's try and add the await on multiple tasks, because I think that's really important, because you could imagine, like, say we get to the point in the game where we want to update the enemies, like each enemy should be updated on a separate thread. Okay, so we want to be able to wait on all those. The threads create a bunch of jobs, put them in, the thread system picks them up. And then resumes, right? There'll be some issues around what thread we resume on, so I think that's going to be interesting as well. Let's spend some time doing that. Let's finish off the 3 bits I wanted, which was await on next frame, await on timer, await on multiple jobs. We might have to add the ability to force what thread we resume on, and then anytime we've got left, I think we should do some refactoring and some tidying up. Like, I already detest this. We're going to have to wire in the exceptions. Yeah, let's take Sunday to kind of round this up, and then I think hopefully by the end of Sunday we can kind of put a pin in this for now, and then we will, any small tasks I'll finish off offline, and then we'll move on to adding physics, because I really want to walk. I want to shoot something, but I think we need to walk around first. I don't know. It depends on how you view the outcome of that video. I wouldn't say I hacked it. I reverse engineered the keygen, and then I basically failed pretty hard at, what is it, safe disk, but I've learned a lot since then, and maybe I'll give it another go one day, because I think I'm definitely better than I was then. Loads of stuff. No sound yet. We'll get there. I have sound code already, so we can import that in. I mean, there's loads of ways we can take this, right? Event source, whatever. I've got kind of a bit of a vision, and I'll probably start building that out, and then we can always improve it later. It's true. I did my best on that one. Occasionally I have a creative burst. Right. Let's see if anyone's doing C++ and send some people their way, because that'd be nice. Other than that, you should join the Discord. It's great. I'm there. No, it's not great because I'm there. Sorry. I just realized how that came across. It's great, comma. I am also there. Building the what was the people who raided last time to the guy who was building his own programming language? What do we think? There's not many other people doing C++. Was he good? Was he interesting? Is it worth sending some people his way? Oh no, wait a minute. Here we go. No, I found someone new. Vulkan Game Engine, C++, late night, 3 viewers. Let's go. You guys go say hi. Could be nice. Oh, he's got vibe coding as in his description, so I'll leave it up to you whether that's what you want or not. But right, let's. Oh, he's using SharePointer. I will reserve judgment. Haran just got smacked down by Nightbot. Right. Right now. Off you go. Have fun. I will see you all anon.